Hello to all. I am Dr. Alkesh Agrawal, and in this lecture, I'll mainly discuss about a five-variable K-map and how it is being used to minimize a Boolean function. These are some reference books that include Digital Design, authored by M. Morris Merrow and M. D. Saletti. Another book is Modern Digital Electronics, authored by R. P. Jain. So, as I've already discussed in previous lectures, that there are mainly two methods by which we can reduce a Boolean function. One is Carnot mapping method, and another one is tabular method, and it is also known by the name Cohen-McCluskey method. So in this lecture, I'll mainly focus on five variable K-maps. So first of all, we have to understand the structure of five variable K-map. So as I have discussed in previous lectures, for three variable K-map and four variable K-map, we have only one distinct map, but for five variable K-map, we have two different maps. One map is for, as you can see over here, is for v is equal to 0, and one map is for v is equal to 1. So if you look into this table, we have five different variables. The least significant bit is z, and the most significant bit is v. If we concentrate on these four variables w, x, y, z, so we have combinations starting from all zeros to all ones, and this v variable is 0 for all the combination. Now if we see this table here again, if we concentrate on these four variables w, x, y, z, so again the combination is with all zeros to all ones, but the difference is that this v variable is 1 for all the combination. So here now we can understand in a better way that for this map we have put v is equal to 0. So this variable, the most significant bit, is not depicted in this map, but it is outside the map, because for all the min terms this is being fixed to v is equal to 0, and other than this most significant bit, all other variables are being depicted in this map. So this is an individual four variable map, and this fifth variable is outside of this map, which is depicting v is equal to 0, and again this a four variable individual map, and the fifth variable here is v is equal to 1, because for all the min terms v is 0, and for all the min terms that are being depicted in this map, v is equal to 1. So if we see, the first min term is m0, and the last min term is 0, 1, 1, 1 is m16. So we have in this map min term m0 to m15. Now in this map, the first min term is m16, because the first combination is 1, 0, 0, 0, 0, which depicts decimal equivalent 16. So we have first min term is m16, and last min term, which is for this combination of all ones, is 31. So last min term is m31. So again, another important thing is, out of these two maps, the first map, which is for v is equal to 0, the min terms are from m0 to m15, and the second map, which is being for v is equal to 1, the first min term is m16 and the last min term is m31. So in all we have 32 min terms with all zeros to all ones. So half of the min terms are in this map and half of the min terms are in this map. So 16 min terms are in v is equal to 0 map, and 16 min terms are in v is equal to 1 map, where w, x, y, z are in gray code. So this w, x are in gray code, and this y, z variables are in gray code. Similarly, w, x in this are in gray code, and y, z are in also in gray code. So next important thing is, this map is assumed to be overlapped over this map, so that this min term is coincides, this m0 min term coincides with m16, m1 coincides with m17, and so on. So this whole row coincides with this whole row, this whole column coincides with the whole column, and so on. So what we assume is this whole map is being overlapped over this whole map. So now we have to focus on these two maps in order to make the biggest group out of the min terms or max terms. So this will see in subsequent slides that how we can form the biggest group of minterms that can be common to both the maps in v is equal to 0 map and v is equal to 1 map. So this is a very simple example where the minterms where a boolean function is given of 5 variable v w x y z which comprises of minterms 0 to 5 7 8 10 13 15 16 18 21 23 24 26 29 31. So out of these minterms from minterm m0 to m15 will be plotted in v is equal to 0 map, and minterms 16 to 31 will be plotted in v is equal to 1 map. So we have plotted minterm m0, m2, m5, m7, m8, m10, m13 and m15 in v is equal to 0 map, and minterm m16, m18, m21, m23, m24, m26, m29, m31 in v is equal to 1 map. Now, as I have already told you, we have to focus on individual map as well as on both the maps. So first of all, we see that in this map all the cornered minterms are being plotted, which forms a group of 4 minterms in this map. But simultaneously we can also see that in v is equal to 1 map, again all the cornered minterms are again plotted. So in this map also we have a group of 4 minterms of these cornered minterms, and since I have told you that this is being overlapped with this minterm, this m2 minterm is being overlapped with m18, m8 will be overlapped with m24 and m10 is overlapped with m26. So these cornered minterms in this map will be mapped on the cornered minterms of this map to form a group of 8 minterms. So we have this bigger group, group 1 of minterms m0, m2, m8, m10 combined with m16, m18, m24 and m26. So this is group 1. Similarly, we can see we have 4 minterms forming a group in v is equal to 0 map, and similarly we have these 4 minterms in v is equal to 1 map being grouped together to form a group. And since these positions are being overlapped, so these are overlapping positions, m5 with m21, m7 with m23, m13 with m29, m15, m31. So from these two maps we have a bigger group, 4 minterms in this map, 4 minterms in v is equal to 1 map to form a group of 8 minterms. So like this we have 2 groups, and both the groups have minterms which are from both the maps. So now we'll see how to write in reduced form. So in this map here, then this group is common to both the maps v is equal to 0 and v is equal to 1. So this v variable is being changed from this group to this group. So in the reduced form v will be eliminated. But first of all we'll write from this map. From in this map v is equal to 0. If we focus on these two rows, here wx is 0 0, wx is 1 0, so x is fixed, w is changed, so we get v bar x bar, v bar x bar. And now we'll focus on these two columns where yz is 0 0 and yz here is 1 0, so z is fixed and y is changed, so y is eliminated and we get z bar. So we have v bar x bar z bar from map is equal to 0. From this map we get the same thing except v is equal to 1. So what we got is v x bar z bar. If we combine both these values, so we can have x bar z bar common. So what we get is v or v bar, and finally what we get is x bar z bar. So this is the reduced form for group 1, which is common to both the maps. Similarly in from group 2 we can see here v is 0, so we write v bar. Now we focus on these two rows where x is fixed and w is changed, so we get x. We concentrate on these two columns, so here you can see z value is fixed and y value is changing from 0 to 1, so what we get is z, so we get v bar xz. Similarly for the same in this map, what we get is v is 1, so our instead of v bar we have v and xz. If we combine these two values we get xz common, v or v bar is 1, what we get is xz. So the final reduced form from group 1 is x bar z bar or xz. So here we got this reduced form out of the two groups, and both the groups have min terms uh, from both the maps v is equal to 0 and v is equal to 1. So we see that v variable is eliminated because both the groups are present in both the maps. So this is how we see with a very simple example that we form two groups combining the main terms from both the maps. Now let us discuss one more example. And now in this example, this is somewhat harder example where we have a function in terms of max terms 3, 4, 7, 11, 15, 19, 21, 23, 27, 28, 29, 31. So max term from 3 to 15 are plotted in this map, and 19 to 31 are being plotted in this map. But what we have to uh, understand is for max term we plot 0 instead of 1. So since the given function is in max term, so we plotted 0. So we have plotted m3, m4, m7, m15, m11 in this v0 to 0 map. In v0 to 1 map we plotted m19, m21, m23, m27, m28, m29, m31. Now again, first we focus on a group which will be common in both the maps. So here easily you can identify this column where all the ones are being plotted, and the coinciding column here is this column, because here also yz is 1 1 and yz is 1 1. So the and here also all the max terms are being plotted. So now we have a group 1 which is common to both the maps. So this is group 1. Now then we have this group of max terms combining m21, m23, m29, m31, and we see that in this map these two coinciding positions are being mapped, but here there is no max terms are being plotted. So this group will be confined to v0 to 1 map only. So this is group number 2. Then we see we have another group comprising of a combination of m28 with m29, this group. Although this max term is a part of this group, but again we are using this max term to form a bigger group. So we have a group with max term m28 with m29. So this is group number 3. So here all the max terms are being in one or the other group. Here this max term is being left isolated because it cannot be combined with any other max term. So this will be an isolated one forming group 4. Now we'll try to write in the reduced form. So for group 1, which is common to both the maps, we can see this v variable will be eliminated, and if we see that this for this column wz is being changed, so wz will also be eliminated, and what remains is yz variable. And since we have to depict in POS form, so for in SOP form we get yz, but in if we convert it into PS form, what we get is y bar or z bar. So this is reduced form for group 1. Then for group 2, what we can see is this group is confined to v is equal to 1. So then if we concentrate on these two rows, what is fixed is x and what is being changed is w. So we have x, so we have v is equal to 1, x is equal to 1, and if we concentrate on these two columns, we have z is fixed and y is changing. So what we get in PS form for this group is v is equal to 1, so we have v bar, x is 1, we have x bar, and z is equal to 1 is z bar. So we got v bar or x bar or z bar. For group 3, again this is in confined in v is equal to 1, so we get v bar, and w is again wx are fixed, so we have w1 and x1, so what we get is w bar or x bar. And if we concentrate on these two columns, so we have z is changing and y is fixed, and y is equal to 0, so we get y. So ultimately what we get in reduced form is v bar or w bar or x bar or y. And group 4 is very easy because this is only isolated max term. Here this is in the map v is equal to 0, so we get v, w is 0, so we get W. X is 1, so we get X bar. And Y, Z are 0, 0, so we get Y or Z. So finally what we get is V or W or X bar or Y or Z. Now we combine all the values, we get reduced form as Y bar or Z bar and V bar or X bar or Z bar and V bar or W bar or X bar or Y and V or W or X bar or Y or Z. So this is how this is a reduced form for a Boolean function which was given in max term, and this is a 5 variable Boolean function which is being reduced with the help of a 5 variable KMap comprising of two maps, one for v equal to 0 and one for v equal to 1. Thank you.